see Matt. Is Matt here? Oh, there's Matt, sorry. Since this is the 30th annual GIS in the Rockies, I'd like to take a few minutes to reflect back on where we've been. The first conference was founded by Nancy Tubbs from the USGS and Roger Hoffer from Colorado State University. At the first conference, there were roughly 75 attendees, and it was held at Colorado State University at the Laurie Student Center. The earliest year I could find any details was from 1991, and most of the major themes revolved around capturing and converting data into GIS systems and setting up new GIS programs, which were not really unexpected topics for the early years of GIS. And I thought this was kind of a fun fact. Last year, Jim Castaneri presented a spatial analysis of bicycling behavior in Colorado using census data. And as I was going back and looking at the 1989 program, I noticed a familiar name. In session 10, Bureau of the Census Panel, the single lonely presentation titled The Tiger System and Its Applications with 1990 Census Data Products was presented by Jim Castaneri and Jerry O'Donnell of the Bureau's Census. I thought, how great is it to see someone with such a long history with GIS in the Rockies? Is Jim here this year? No. Figures. So in 91, we had 70 presenters, which I thought was really impressive for that early in the conference's history. Of those 70 presenters, 10% were women. This year, we have 135 presenters, which I think is really great, and I think you guys should all be impressed with yourselves. 28% of those presenters are women, and roughly 41% of our attendees this year are women. I was looking for some other statistics to evaluate how well GIS in the Rockies serves and integrates other sectors of our community, but there's no way to gauge this. So I'd like to share this thought. According to the Center for International Policy, a person is 15 times more likely to be killed by a hurricane in the United States than in Cuba. I know, kind of a random thought, right? But I'm gonna bring it back around. The reason for this is because Cubans have an ingrained culture of prevention and preparedness. All neighborhoods in Cuba are mapped. They know exactly who lives where, including the especially vulnerable. So the elderly, the infirm, the pregnant, the young. And there's an evacuation plan for each and every person. So days before a hurricane hits, everyone is evacuated. There is no last-minute, haphazard approach to disaster preparedness. And all of this begins with mapping each person's location. So this is where I bring it all back around. This example from Cuba made me think about GIS and diversity and how it's coupled in a way that I hadn't really thought about before. How different communities with different values are using GIS in different ways. So I encourage GIS in the Rockies, both the leadership and the community, to think about this as we move into the future. How do we continue to grow this conference in different ways and use GIS in ways that we haven't before? Maybe in ways we hadn't even considered, while we support and include our entire community. I think this is really an interesting and worthwhile challenge. Okay, so changing gears. Wow. Sorry about that. Okay, so what does it take to make this conference successful? It takes a lot of people. It takes two great keynote speakers. We're going to have those up here shortly. We've got Peter Batty and Aileen Buckley, and we really appreciate both of them coming to share their time and expertise with us. We have 4 societies that support us. We have GIS Colorado, Rocky Mountain URISA, Public Land Surveyors of Colorado, and the American Society for Photogrammetry and Remote Sensing. Without them, this wouldn't be successful or possible. We have our volunteers who are core of our success, and without them, we wouldn't be able to put this on. They participate on the board of directors and on our planning committee, and they devote many hours to making this successful. And as as co-chairs, Matt and I really appreciate all their time and effort that goes into this. And Paul Balaguer, who is our event coordinator, he's really, really important to making this successful. We have many other volunteers who volunteer as track chairs, as Career Development Academy professional volunteers. They help staff the registration desk, many roles. And if you would like to volunteer, we really would appreciate your time next year. We want to thank our sponsors and exhibitors. This year, our exhibitors are located in the hallway out front and in the Colorado Lounge. We want to especially thank our presenters. You bring the exciting, innovative, and diverse technical content to the conference every year. You're the core of the conference, and you're what continues to bring, you're what brings people back year after year. Sorry. And, of course, the attendees. We have 509 attendees this year, including our pre-conference workshops, our tours, our exhibitors, sponsors, and registered attendees. So that's really amazing, and thank you all for attending. We hope you enjoy this year's conference. And now I'd like to invite Brant Howard up from One Compass, who is our platinum sponsor this year, to say a few words.
For those of you that, first of all, good morning. Morning. For those of you here last year, I'm going to do a little more traditional kickoff this year than I did last. But my name is Brant Howard. I'm the co-founder and CEO of the One Compass family of businesses. My wife and I started our family business 24 years ago here in Colorado, the greatest place in the world to live, raise a family, recreate, and be in the geospatial profession. I welcome you to the 30th anniversary of GIS in the Rockies. The One Compass family of companies is very proud to again sponsor this great event, one of the greatest regional events in GIS around the world. This event, as Christy says, takes a lot of effort from volunteers. Back in the 90s, I was on the board of this organization. I also was a program committee chairman for a couple years. I would like the volunteers to please stand that have been involved in organizing, helping, and working this event. And Paul, please step out from the wall. Please stand and raise your hand. Come on, everybody stand up that's a volunteer. Stand up. Let's give these folks a round of applause. We had a meeting in our office recently, and Dave, who keeps track of the old programs, and I'm sure you went through some of the old programs to make that statement, was missing a couple years in the 90s. And believe it or not, I had it on an archive of some of the programs we did and gave him that information, which I think you all should do a session next year, just comparing technology over the last 30 years and what we've done. It would be great, very great. We are blessed to live in Colorado, the center, what I call the center of the geospatial world. GIS technology, geospatial data, thought leadership from our community truly impacts the world. One of the keys of this event is to network and share your experiences this week with others that attend. We've done this a few times, and I'd like to do it again today. I'd like everybody to stand up. Please stand up. This is an Esri Jack Dangerman thing. I want you to turn and find somebody you don't know and take a minute to introduce yourself and tell them who you are and why you're here for GIS. Well, that's great. That's a good start. I hope you continue these discussions, meet new people, and share ideas this week. The thought I want to leave you with to kick off this event is to go deep. I know it's football season, and our beloved Broncos are off to a good start, but I want you to think about going deep. Machine learning, AI, and deep learning are not just ideas for the drawing board anymore. They are happening today. The geospatial data, GIS software we have worked with for many years is becoming a real source for deep learning. And that's supposed to support and is supporting machine learning and AI for things like feature extraction from remotely sensed data, autonomous vehicle systems, crop and climate assessments, geolocation of photos for addressing and asset management are all coming out of these automated systems. The ability to identify patterns and objects from big data is changing the way we make decisions. Markets such as the insurance business, hedge funds and investment groups, governments, and transportation are really looking and starting to leverage these. How many of you all think that you'll be riding in an automated car in your lifetime today? Isn't that amazing? And it's all going to depend on our data, deep learning, automated systems. So as you spend time here this week, go deep into the sessions of conservation, survey, education, water. Boy, water. We haven't heard about water in Colorado for a while, but with all this growth, water is going to be a big, big issue for us. Software development, big data, emergency management, and collaboration across boundaries. These are all sessions at this meeting that are really outstandingly put together. Go deep with the people here, networking and sharing to solve the magnitude of challenges we face across our state, our country, and around the globe. The One Compass team thanks you for your support for this event. We look forward to discussing your work and passion in our interesting profession, and we hope you have a great GIS in the Rockies. Thank you very much.
Thank you all for being here this morning. When it became apparent that we would be celebrating our 30th anniversary this year, it seemed like a natural fit to have our first keynote speaker this morning. Peter Batty has been serving the GIS community and geospatial community for the last 31 years. So it seemed like a natural fit to have someone of his caliber come give our keynote this morning. So Peter's going to give us a keynote about the past, present, and future of GIS. And so let's all give him a warm welcome as he takes us on his journey.
Just turn that one off. Can you guys hear me? Yep. Just switch presentations here. Yeah, so thanks, Matt. So as he said, I'm going to talk to you a bit about the past, present, and future of the geospatial industry, which as I put the information together, I suddenly realized maybe I was being a bit ambitious to cover all of that in an hour, and I had an hour and a half worth of material a few days ago, but I'll touch on a few things. But I talked to Matt and Christy last year when I was at GIS in the Rockies, and it occurred to me I gave the keynote here in 2010 and 2003, so I thought there would be a nice symmetry if I could do it in 2017 and keep that 7-year pattern going. And as he said, I've been in the industry for 31 years. I started in 1986. And so I thought it would be kind of cool to keep going back in 7-year increments and then try and look ahead 7 years, so that's what I'm going to do. And we'll talk about 87 briefly, because that was the first year of GIS in the Rockies, but not too much difference at that distance. And before I get into that, I'd ask you to think about what was the biggest change in the industry, or which time interval did the biggest change in the industry happen. We'll probably all have our own opinions on that. And then my focus has really been on the sort of the infrastructure space, if you like, primarily utilities and telecoms, to some degree water, local government. And I think, there are certain differences there. But anyway, I'll tell you my choices for which time interval the biggest changes happened. And it was kind of interesting, because overall you would think change gets faster over time, but which obviously it does in general, but sometimes it's unevenly distributed, and I was kind of surprised by the result. So we start off in the past, 1987, 30 years ago. Just to give a bit of reference, that was the year of the drive. Elway came back against Cleveland. I've been in Denver long enough to be a Broncos fan since 1993, I guess. And on a more global stage, the Berlin Wall was still standing back then, and that was when Reagan gave his famous speech, and the wall came down 2 years later. So just to set a bit of historical context, it's been going quite a while. And from a technology perspective, it's kind of interesting. I'm sure you're all familiar with Moore's law, which says that basically the power of computers doubles every 18 months. And it's crazy how these exponential series work. So any quick guesses how much less powerful computers were 30 years ago? 1 million times. I mean, it's actually pretty hard to believe that, but basically, if you take 10 iterations of Moore's law, that's 15 years. That's 2 to the 10, which is 1,000 times less powerful. So 30 years is 1,024 squared, so slightly more than 1 million. So hard to believe what we did back then with that kind of capability. So let's talk about 1989, and what I'll do in these is just say when I actually got the time, I had to cut things down a little bit, but I'll take a few interesting snapshots of how the technology was at the time. I'll look a little bit at what we were predicting at the time and how that came out, just to give a flavour for how things have developed. So in 1989, I was working for IBM. I joined them out of college, having studied computing just to be a general systems engineer. And on the first day, they said to me, we brought this new product from the US. I was back in the UK then. It was called GFIS, which was their product, their GIS product focused on utilities. And so at the end of the first week, I was the UK expert because I was the only one who read the manuals. And I've been in that field ever since, and found it really interesting, though I'm not a geographer. But I have always just felt it has this interesting mix of things technically, from database technology to application development to graphics. It's just got this generally interesting appeal. So back then we ran on IBM mainframes with the GFIS system. There were some people running on VAXes and other things around that time. That was the top of the line kind of mainframe, 128 megabytes of central storage. We ran on these high-end graphics workstations, which I was talking to my friend Dennis Beck. Some of you may know Dennis. He's been active in the Denver geo community for a long time and also worked for IBM. And he told me they cost $125,000, which was even more than I recalled, including the special network controller that you needed. And he also said that one of his customers who installed the GFIS system had to do a $10 million upgrade to their mainframe system. So it was certainly in the orders of magnitude more expensive for doing things that were a lot less slow. So maybe that $1 million or that million times factor is not too crazy. As well as talking about technology, I'll just mention who the players were in the industry at different times here. So this is my recollection of the main players, say in the kind of infrastructure space where I worked. So IBM was a big player back then with this GFIS product. Synacom was perhaps on the decline at this time, but they'd been around and had a pretty good market share. Esri was there with, I think this was the logo at the time. I tried to look a little for the historical logos as I went through. Intergraph, who are still around, of course, and GeoVision, who you may or may not know, but they were doing a lot of innovative things at the time. And if I think back to what were the sort of main technical challenges we were trying to solve at that time, most of those systems really had an architecture, and I'm a sort of technology guy, so a lot of this stuff is focused on the kind of architecture sort of things. But basically, a lot of systems then had an architecture where you'd have graphical files, which were typically tiled, mainly because of machine constraints. You couldn't load too much in there. And then a separate set of attributes, relating back to those tiles. And it was kind of problematic. You had to split things every time they crossed a tile boundary, lines or polygons. And that made a number of things difficult. So a big quest in the industry was really moving away from tiles. And I find it kind of ironic. A lot of things go in cycles, but a very fashionable thing these days is vector tiles. And people laugh at me. I keep saying that they're a transitional thing and they're not going to last long because they have a lot of the same issues. I mean, you can do some cool things with them, but really there's a lot of attractions to be able to have this continuous database. And then, so another debate as you were trying to move to that sort of storing things in a continuous geospatial database was what should you store it in? And back at that time, IBM was one of the main advocates in the industry for storing things in a standard relational database. And I wrote this article back in 1990, which was published in a few places and got quite a bit of coverage on the reasons why it was a good thing to store your data in a standard relational database, which really wasn't common back then. So IBM was a pioneer in that, and GeoVision also, who I mentioned on the previous slide. We were really the two companies pushing that, but most of the other companies didn't. Before ArcGIS, there was ArcInfo, and that name came from Arc was kind of what stored those graphical files that I talked about, and Info was a simple relational database, so that came from those two sides. This is what our system architecture looked like. It's a diagram from the time with where you had DB2 in the middle was IBM's database, and then you kind of had to extract data from that database in order to sort of load it into memory and work interactively with it. You could edit it and then push that data back. And typically those extraction times were in minutes in most systems. So, before you could actually do anything, you had to kick off this job, wait a while, even tens of minutes in some cases. So it was quite different back then. And a lot of the focus with data back then was capturing data from paper maps, again, in the space I was working in using digitizing tablets. So for those of you who are not familiar with them, here's kind of what they look like, but you would tape the map onto the tablet and then click with the digitizing tablet. It was quite difficult, somewhat error-prone. You had to remember which things you digitized. You couldn't see that graphically very easily. And then, in general, the quality assurance involved plotting out the map, putting it over the original document, putting it on a light table and comparing them. So it was a pretty laborious process. So between that and the hardware and software requirements, really the people who did projects back then were real pioneers. They were spending millions and millions of dollars. And I thought I'd mention as a side note, actually, Xcel Energy was PSCo, Public Service Company of Colorado back then. They were a real pioneer in the industry. We already heard, Colorado is a real center of geospatial technology, but they worked with IBM on early versions of their product back well before I was involved in that. One little side thing I thought, and I'll tell a few stories just about how the industry developed and the players in it. But in 1989, IBM embarked on a new project to develop what they imaginally called a new GIS was their name for it. It might have had a different name if it had ever been released, but it was a lucky career break for me that I got chosen as part of the team. Now, I was quite young at the time that I worked on the design of that. And there were about 10 or 12 of us spent a couple of months in Kingston, New York in the winter of 1989, 1990, trying to design this, we came up with a design for this great new GIS that was going to be the market leader and everything. IBM put loads of resources on it, literally up to 200 people at one point. But long story short, after 2 or 3 years, it hit a lot of problems with the development and ended up having the plug pulled on it. But if that had happened, I think the industry might have looked quite different because IBM had these huge resources and really was quite ambitious at the time. And those players I talked about, Esri was nowhere near as dominant back then. They all had a relatively equal share in the market. So let's go forward to 1996 and look at the players in the market. You can see that Synacom, GeoVision, and IBM have really all dropped off the list. Esri and Intergraph are still there and will be through the whole thing. But the new players here were Small World and MapInfo. And at this time, I was working for Small World. I moved there in 1992 when they were a small UK company. So basically, this IBM project I mentioned, I had concerns it was running into trouble and wasn't going to happen. And I ran into these Small World guys by accident, and IBM, I think, had 300,000 employees at the time. Small World had about 30. But whereas IBM was trying to look at what everybody was doing in the market and take the best of that to build this great new system, Small World, I felt, really had some radical new ideas that IBM and others hadn't thought about at all. So I was very excited about what they were doing, and I moved there. And I worked for them for a year in the UK, and then in 1993 I moved over to the US. And that was probably the most exciting time of my career in many ways. Small World had technology which was way ahead of anybody else at the time, and even though we were this small company from the UK who nobody had heard of, we really sort of dominated the wins in the utility and communication industry through the 1990s. And we were kind of helped by the fact that IBM had pulled the plug on this product because all the IBM customers had sort of been told the old GFIS system is, needs replacing, we're going to build this great new product. So they were all in a mindset of looking for something else. And I knew the IBM GFIS product, so that really helped us because we could help people migrate the data. So that, to me, was an interesting time in the industry, especially in that section of the industry. And some of the key things that Small World came up with were these things that are listed here. It's a picture of Cambridge in the UK, which is where Small World is based. But version management was one of the big things, which was kind of obscure, but it related to how do you handle sort of future versions of the data, if you like. That's important for infrastructure companies. You want to design an extension to the network, see what the network's going to look like a month or a year in the future, and also track history to some degree. Interactive access to large databases. I mentioned that at this time, in general, you had to do these lengthy extracts that could take minutes before you could see anything. And the Small World architecture, they developed their own database, let you just pan and zoom everywhere and view it very quickly and be very interactive, and that was a huge step forward. Object-oriented programming, they were leaders in that at Small World, and this really let us develop things much faster than other people could at the time, and we could extend things in the system very quickly. And raster vector integration was a big thing, so basically instead of digitizing off a digitizing tablet like I showed, the approach that Small World used was to be able to scan paper maps in and then digitize them over them on the screen. And there was some kind of automatic line following where you could just press go and it would follow a curved line automatically. And so it was much easier to do quality assurance and see that you'd really captured everything. So all those were quite radical things, and as I say, Small World really won a lot of business in the early 90s. And I'll come back to how the other companies in the industry responded shortly. But so having argued how you should store all your database in a mainstream relational database a few years before, I wrote an article in a little bit later here with the Small World guys saying GIS databases are different after all. And so this is something where I think I've swung backwards and forwards, and as things develop, as technologies develop in different ways, there are pros and cons to, should you use some more standard technology or do you need something more specialized? But at the time, these innovations that I talked about in the Small World database really made it compelling to use their own database because it just had a lot of advantages over using Oracle or DB2 or something like that. And that was something I had a lot of debates with IT people at the time and over the years. So another key thing in 1996 was that MapQuest.com came online. That was really the first web mapping site. And I have to say, I really didn't realize the significance of it at the time, and I don't think people did in general. It was a cool site, but it was really quite slow, not very interactive. When you panned, you had to wait quite a few seconds, and the map would draw again. You couldn't put your own data on it. So at that time in '96, looking back at presentations, we certainly weren't talking about, web mapping is going to be the future. That came in the next iteration. The other thing that kind of kicked in during this time frame was GPS. I mean, it had quite a long history of experimentation and development, but basically 1995 was when it was declared to have full operational capability. Though we still weren't quite there at this time, it still had selective availability, which was this sort of intentional degradation of the signal, so you couldn't get good accuracy if you weren't in the military. So 2000 was when that was opened up, and then it really started to grow for non-military applications at that point. So let's skip ahead to 2003. And so really the main players were all the same. Say GE Small World, or Small World had become GE Small World, so they were acquired by GE in 2000. And as often happens with these acquisitions, a lot of the original founders and early employees are the sort of entrepreneurial ones, and we want to go on and do something new again and don't necessarily want to be in that big company. So I'd left at this point to start a startup called 10 Sales that was looking at various new opportunities at the time. But really those top four were the big players. I put Oracle on here even though they're not a GIS company per se, but I felt at this time they had quite a lot of mind share in the space that we were in. They put a lot of geospatial functionality into the database, into their database product. And they were very dominant in the large enterprises that we worked in. So there were a lot of people, a lot of IT people saying you should store all the data in Oracle, and they certainly played in the thinking there. There were quite a lot of people arguing the way to share data through the enterprise is just to put it all in Oracle, but that never really panned out because there was enough kind of metadata and information about styles and symbology and modeling networks that was different between all the products. So even though most products used Oracle to some degree, that was overly simplistic to say you could just share information at the database level. However, one significant thing that did happen, although Esri and Intergraph are on both of these slides, is that they both had new products at this stage. So in 2000, Esri brought out ArcInfo, what was originally going to be called ArcInfo 8, and they renamed that ArcGIS. And that was a major redesign from the previous iteration of ArcInfo. And a number of senior people at Esri told me that was really driven by those changes that Small World had made. So although, you know, Esri clearly dominates the industry now, Small World's focused in this niche and probably hasn't, well, certainly hasn't grown the same way. I think those innovations that Small World made back in the 1990s drove both Esri and Intergraph to develop new products. Intergraph also developed a new product called G Technology that succeeded their frame product. But both of those are still really the products, well, those three really, Intergraph, Esri, and Small World, are all really the active products today still in that industry. So they're mainly products that were designed in the late 1990s, 2000s. Esri is going through some new changes now, but those on the whole haven't come into that industry. So that portion of the industry that I've worked on has generally been, you know, relatively static, I would say, relatively slow moving. And so 2003 was also the year I gave my first keynote at GIS in the Rockies, and so I pulled a few slides from that presentation. Well, in fact, I couldn't find the exact presentation. I found a couple of other presentations from around the same time, but my archives were flawed. But this was the first time one of the first times I used this slide, which has been a slide that has appeared in almost every presentation I've done since, about disruptive technology, which is taken from Clayton Christensen's book, The Innovator's Dilemma. And I really recommend this book if you haven't read it. It's very applicable to our industry, and there have been a couple of iterations where we've seen this. But his general thesis about disruptive technology is you have a technology market, and he gives all kind of examples from disk drives to steel mills and, you know, all sorts of different industries. But basically the requirements of the market increase at a certain pace, and the ability of technology to meet those requirements increases at a faster pace. So once you have a product in the market, it increases in capability and reaches this stage where it's kind of at the top of that band of requirements. So when you get a new release, and this certainly applies to the mature GIS products in general in our space, when you get a new release, you're not doing something really radical that you couldn't do before. It's mainly, you know, fine-tuning here and there. But then in the meantime, you get what he calls disruptive technologies that aren't powerful enough to apply to that mainstream market. So usually they apply, you know, in some other market. But they increase in capability too, and then at a certain point they reach the stage where they can be useful in this established mainstream market. And I think we've seen this happen a couple of times, and in particular I would say the biggest example is Google Maps, which we hadn't got to yet. But so the interesting thing, it was in 2003 I talked about this slide, and I said I felt that we were ripe for a disruption in the geospatial industry because we had these pretty mature products, and it just seemed like this sort of model. And at the time I thought maybe Microsoft MapPoint was going to be the thing that did it, which was a sort of simple, very easy to use desktop product. But as it turned out, 2 years later, it was Google Maps that kind of fit this model. But it was kind of interesting that was a prediction that I think did work out. So I now have a couple of slides. I say I couldn't find my GIS in the Rockies one, but the closest one I found was a presentation I did at GIS Brazil. So you can practice your Portuguese while you look at these slides here too. But I just pulled a few slides out because I thought it was interesting to see the things I was talking about at that time. So certainly this theme of, you know, making more use of mainstream databases was a big theme at that time. You know, I say at the bottom, I think that you still couldn't really just use the databases and draw directly from them at that time. The performance wasn't there. So as a GIS vendor, you had to do smart things with caching or something to get the good interactive performance that you really needed. The internet was starting to be a thing. I mentioned in '96 we didn't really realize the significance of it, but it still wasn't being heavily used here, but it was starting. And I think a couple of interesting comments here. I said the internet is not just web browsers, much of its impact is as an all-pervasive network, and that in GIS a key impact would be interactive access to spatial databases anywhere in the world, and certainly that has come true. There's an interesting little snapshot of the cutting-edge technology of the time. So GPS was starting to be mainstream. In general, a theme that I've always been interested in is what's available in the consumer world, and I'll return to that topic shortly. And then here's the cutting-edge hardware of the day as well. So most of which don't look terribly familiar. I kind of remember the PDA there, but anyway, there you are. And so what about GIS? So I thought this was actually kind of a pretty good prediction. The first one, it says in 3 to 5 years, you'll be able to do much more than you can today with a device which fits in your pocket and is also your video, phone, personal organizer, knows exactly where you are located, talks to all the other devices around it. And the iPhone came out in 2007, so I claim that was a good one, I think. But I didn't, obviously, the interesting thing here, there were a couple of predictions. One kind of was Google Maps, and well, not directly, but but at the time we had no idea who was going to do that. But it turned out that Google and Apple kind of got involved from completely outside the industry, and also that you can access not just your organisation's data, but lots of other data sources. And again, that's been a big theme. But back then, GIS was very much focused on accessing your internal data. And then this has been a perennial question, more or less through my whole time in the industry. I think I remember back in 1992, going a bit further back, Doug Seaborn, who was the head of GeoVision, did an interesting paper at the GITA conference, which was called, I think it was 1995, the year that GIS went away. And the general theme of that and this sort of question here is always, well, geospatial technology is being embedded in many more mainstream technologies, so will GIS go away as a specialist thing? And I guess my answer would still be kind of yes and no, as it is here, that even more so today, and I'll come back to this, there's all kinds of technologies that embed very sophisticated geospatial functionality. So whereas back in these early days you had to have a GIS to do anything with spatial and push data in and out of it, now you have a lot more capability to use broader technologies, but then there are still clearly applications and needs where you have a more focused, specialized GIS product. But the industry is kind of diversifying in that way, and we'll talk more about it. And say here, I said, much of what is provided by GIS vendors now will be provided by Oracle and Microsoft, whoever has taken over from them. So probably plug Google in there too. So again, some of those predictions were all reasonably good, I'd say. So moving on to 2010, this was my next presentation at GIS in the Rockies. Still basically in the utility and telecoms industry, it's the same main players. Intergraph had now become Hexagon. And actually, right now, my personal career path I spent 2 years as CTO of Intergraph in the intervening period, but then in 2010, I'd just come back to Ubisense, which was the company that I'm at now, and which had evolved from 10 sales. And I did a few other things in the interim, some social media applications and things like that. However, this was really the state of play, I would say, in the core infrastructure geospatial industry. But the really big change was that Google had appeared. And to me, that was just a huge change for the industry, and that was a lot of what I talked about in my talk at GIS in the Rockies in 2010. So I just pulled a few slides out from there to show kind of how I was presenting it. The title of that talk was The Geospatial Revolution. And to me, the revolution was the arrival of Google. And I just pulled out a few slides where I talked about that. But the general theme, and this is still a theme I talk about, that location is now pervasive and simple in consumer applications. So, how do we leverage that in the more complex applications that most of us are involved in, the sort of enterprise applications? The disruptive technology slide got another outing, as it always tends to. But another theme that I talked about there, which it is slightly different from the disruptive technology one, is the idea of consumer-driven innovation, which is something that industry analyst Gartner talk about a lot. And I think this is very, very relevant to the geospatial industry and becoming more so. So, you know, it used to be that innovations would happen first in business or in government and then trickle into the personal space sometime later. But now the personal technology markets are so much larger that in general innovations happen in the personal space first and then come into enterprises and businesses later. So a couple of great examples are smartphones and tablets where, you know, sure everybody here is using them, but I bet a lot of your enterprises aren't using them for geospatial apps yet. At least that's what I see in utilities. They tend to be slow adopting. I mean, it's starting. You know, gaming stations or gaming technology is another area. And Google Maps is yet another one where Google's doing a lot of innovations that are useful to us in enterprise apps, and they have a scale that goes beyond what we can do within the core GIS industry. And, you know, I would still get a lot of feedback and still do to some degree saying, but, you know, all of these consumer-focused things are not just simple web mapping, they're not GIS. And probably most people don't think that now. Maybe a few still do, I don't know. But certainly back then I got that kind of pushback quite a bit. But one thing I demonstrated and talked about there was, this is what I've been working on basically since that time as an application I led the development of called My World at Ubisense. And it's very much, you know, focused on these enterprises, utilities and communications companies, but has the look and feel of Google. And it's kind of it was a web application back then, now it's web and mobile. And I really felt this was an example to try and prove this point that you can take Google as a foundation and do these serious enterprise applications on it. So just to quickly skim through the other things I talked about in 2010, I talked quite a bit about different approaches to integrating with Google and how you could incorporate in enterprise applications. Talked quite a lot about usability, which has always been a key thing for me, I think. You know, it's a generalization, but a lot of time when we have our heads down in GIS, it's easy to sort of forget what typical end users who are not familiar with GIS understand. And really we can take lessons from Google and others in designing systems that are simple. And it's a lot harder than it seems often to design really usable systems. Talked about the cloud quite a lot, and an interesting thing, when we released that first version of our My World app, it would only run in the cloud. And I felt convinced that was the future and the way to go. But all the utility companies we showed to said, that's great, but we're not going to put our data in the cloud. You need to re-architect it. So I had to kind of pull back from that. But I'll come back to this because I think it's getting more and more compelling. The changing nature of geospatial data, I talked about quite a bit, and I'll come back to that as I talk about the future. I think maybe this has happened a little more slowly than I thought it might at the time, but was really talking about sort of multimedia type data, so things like Google Street View, you know, more imagery, 3D models, that kind of thing, becoming much more rich and diverse. You know, it's not just points, lines, and areas anymore. It's a lot more than that, and so that's certainly an ongoing trend that I'll talk more about. But it was beginning then. And then crowdsourcing I talked about. So another important thing that developed in this time period, 2003 to 2010, was OpenStreetMap, which you know, has had a major impact and has continued to do so. And the whole idea of crowdsourcing is applied in lots of different places. And that certainly continues to be an important thing. Looking back, a couple of things I was surprised I didn't talk more about. Again, it is quite interesting just to go and look at these snapshots and see what was current at the time. One was mobility. I think looking back that the other really, really significant thing was in that period from 2003 to 2010 was the introduction of the iPhone and the iPad, and then obviously you've had all kinds of smartphones and tablets since. But a lot of geospatial work, especially in my field, tends to be done in the field, and they're just such great devices for field work and really revolutionize what you can do. So I think that was a significant thing, and I mentioned it in passing, but not as a really key feature. And then the other one was open source, which I'll talk about a bit more today. But I really got introduced to open source in 2007, I guess. I went to the FOSS4G conference in Victoria in Canada and spent a lot of time there. And really my eyes were open. There was just a lot of interesting stuff there. And I'll come back and talk a bit more about that shortly. And while we're talking about the impact of Google, I thought I would also mention that I think one of the greatest things ever in the industry, technically, is the idea of slippy maps and the web Mercator projection. And I know a lot of probably geographers in the room may not like Web Mercator because it's not conformal and it doesn't do all the things that a proper projection or coordinate system should do. And I guess for those of you who aren't familiar with it, this is the coordinate system that Google Maps and all modern web mapping systems use. And it essentially makes some simplifications so that it's very easy to do in JavaScript, and it was really a key sort of underlying technical innovation. And then the slippy maps gave you this very interactive feel where you can pan maps around, whereas before you had this multi-second delay. So this was a very simple idea, and it got adopted by everybody. You know, Google did it, Bing did it, everybody who was doing maps did it, Esri did it. You know, and to me, this has probably been the biggest single thing for interoperability in the industry. You know, notwithstanding all the great efforts by OGC and people like that, but practical day-to-day interoperability in the sort of web applications we build today, every system can deliver you these tiled maps, and they can look exactly like they look in the native system. So I just think that was a really underestimated invention by a lot of people. So that's the past. Let's move on to the current time, 2017. So if we look at the players in the industry today, the main one I'd add to the list from the last time is open source. And I say I'll talk a bit more about that. But in many ways, I would say in the overall heavyweight geospatial industry, the biggest challenger these days to Esri's dominance is open source, I think, rather than any of the other players. I'd say that GE, Hexagon, MapInfo all tend to have their little niches, and they've still got their customers, but you know, they're not as actively developing as Esri in the open source world. To me, that seems like those are the major areas. Google is still doing a lot of interesting things, but they sort of put a toe in the water of the enterprise space and kind of pulled back. There's still things that you know, developers can leverage from Google, but they're really the enterprise geospatial space just isn't big enough for Google to be interesting to them. But I think, you know, more generally now, if you look at the overall geospatial market, it becomes harder and harder to define it as a separate market because, like I mentioned before, there's just geospatial technology embedded in all of these different large companies. You know, you can read the list. I won't read all of them, but Google, Apple, Amazon, Facebook are all doing interesting spatial things. None of them are using technology from, you know, Esri or Intergraph or Small World. You know, they might be using some open source things. And, you know, maybe they're using bits of Esri here and there, but in general, it's embedded in mainstream technology. And then on the right-hand side, there's a list of sort of smaller, newer companies who are all doing interesting things. So there's this much greater diversity in the industry now, I think. And if I look at trends in the space that I'm working in, oh, sorry, I missed a little build there. I will say that I think so there's some non-obvious entrants as well. So people like Uber and Tesla are enormous geospatial developers and data creators now. Uber's doing all kinds of clever things with geospatial algorithms. And I'll come back to Tesla, but Tesla is like a huge data capture operation now. And so we'll come back to that when we look at the future. If I look at the space I'm working in, the sort of utilities and comms and the general trends that I'm seeing there, like I mentioned, usability was a big one, trying to get more adoption of Google Maps. You know, in some ways it's probably gone a little slower than I would have hoped it would, and that's probably partly just the conservatism of some of those organizations. I'd say we're probably seeing more, and then, you know, mobility is probably a bigger trend now with people moving to smartphones and tablets in the field. Older systems out there were generally designed before that, and there's just a lot of advantages to going to those things, and I'll talk a bit about mobility. And then one of the exciting things I see coming up is reality capture, and I'll talk more about that. But I would say overall I'm probably seeing the fastest change in terms of users in the communications industry. That we work with quite a lot of large cable companies, and they're all looking at completely rebuilding their fiber network over the next 5 years, and so they have a lot of critical time pressure to do things more efficiently, get better systems out in the field. I think we're seeing gradual migration in the utilities, but there's not quite the same compelling urgency to change now. So let me talk a little bit about open source software, as I think that's an important thing in the current day. There's two major organizations that kind of promote open source software in the industry. OSGeo, which has been around for quite a long time. I spent a couple of years on the board. They organized the FOSS4G conference, which was here in Denver in 2011, and I chaired that conference. Location Tech is a newer entrant, and they're probably a bit more commercially focused. And in general, they work together on a lot of things. I'd say Location Tech has a bit more of a commercial focus. These are some old statistics, but just to give you an idea of the scale of the geo industry, this was 3 or 4 years ago, and these were the products that OSGeo are under the OSGeo umbrella. So there's 27 different products in all kinds of different geospatial areas. 17.5 million lines of code, 440 annual contributors. So, in effect, a development team of 440 people there, 900 all time. And so for a small company like Ubisense, we're a couple of hundred people. We can leverage this huge extended development team to do something that really, takes us way beyond what we could do with just our own relatively small development team. I think a common misconception about open source is that doing open source development is not a hobby for a lot of people. I find that some people who are not familiar with open source think it's just, people in a garage in the evening writing a bit of code here and there outside the day job. But the majority of open source developers get paid by their companies to do it. And there's a few different models there. Some of them are doing consulting services and whatnot, but there is this whole industry supporting the open source world. And, I'd say some people believe in open source more from a philosophical perspective. They just believe it's the right way to do software development. I'd say, I come at it from a pretty pragmatic perspective. So when I'm looking at what tools should I use to develop a solution for a customer, these are the kind of things that I look at. So functionality, obviously, if it doesn't matter whether it's open source or closed source, if it doesn't have the functionality you need, it's no use. Cost. Obviously, open source software is free, so that's attractive. It's free as far as the license goes, but you still have support costs and implementation costs and whatnot, so you have to keep that in mind. But nevertheless, it's nice, especially if you're doing web implementations. You want to scale up to more servers and that kind of thing. You don't have to worry about licensing constraints. Though it's interesting, a lot of open source advocates rate cost as one of the least important reasons for choosing open source. Support, some people feel uncomfortable with open source because they want to sign a clear contract. This is who I go to for support. And there are people in the open source world who will give you that. That on the operating system side, you've got people like Red Hat who provide support for Linux. And in the geospatial world, probably the closest thing is Boundless. They support some of the common geospatial products. But also, I find you get very good support from the community. I've only had one time where I had a serious bug. That was some memory leak where we'd suddenly expanded the number of users. And I got a fix the next day from the developer. And I've never got that from a sort of commercial closed source company. It's typically a much longer wait. And obviously your mileage may vary, but my experience has been good. Flexibility, so you always have access to the source code, so you can extend it, you can make changes and push changes back to the developer. So there's a lot of nice flexibility there. And terms, and I think this was a very important thing. So when we started out with our My World software development that I mentioned, we were building on top of the Google Maps API. But then a lot of our customers wanted to be able to work offline, and Google specifically prohibit you from working offline, either with their data or their code. And so we switched to using open source libraries instead. We used the Leaflet JavaScript mapping API, which is an alternative to the Google Maps API. And we can download OpenStreetMap data. So we still use Google as a data source when we're connected, but switching to open source really gave us this flexibility to do things that Google terms prevented us from doing. So in general, you have more freedom that way with open source. And then I'd say predictability, and by that I mean, if I'm using an open source project, I know that that's going to be there tomorrow. I know I have access to all the source code. I can see there's a dynamic community on the product that I'm using, and they're from multiple companies, so there's no one person can say we're not going to support that anymore. And that actually became very relevant looking at what Google did. So I mentioned, Google developed a few more enterprise-focused products like Google Maps Engine, which I never really rated as a product. To me, it just wasn't nearly as good as consumer Google Maps. But Google was pushing hard to use that, but then they didn't get much adoption and they withdrew it again. So if we developed on top of that, we would have had to do a lot of redevelopment. So I think those are all good reasons for considering open source. And at least as an option, it's not an all or nothing thing, so that in general there's good interoperability. So if you're using other products, you may well find areas that open source could help you. And so I'll just give you a quick flick through some things in the open source world. There's a project called OSGeo Live, sponsored by OSGeo, and This is basically a virtual machine that you can download, put it on a CD or DVD, or run as a virtual machine, and it has a whole host of open source products installed and with some test data. So if you want to experiment with things, that's an easy way to do it. I mentioned Boundless. They're a pretty well-established company. They work quite a lot in, especially in federal government space, but they work a lot on enterprise projects doing consulting and providing support for open source. This is Carto. They have a really nice hosted site, which is very nice for doing sort of nice analytics and thematic maps. It's super easy to upload stuff. You can just drag a shapefile onto your browser and have a map up in like 30 seconds or a minute, and it's free to try. And none of these people I have any association with. I'm just trying to give you an idea of the range of things out there that I think are worth trying. Mapbox is another company that has a lot of the top developers in the industry, and they're doing a lot of innovation right now. They've been driving a lot of the work with vector tiles that I mentioned. They're probably more focused on providing developer tools. QGIS is a specific product that I thought I'd mention. You know, if you go back a few years, I think a lot of people would say open source was good on sort of web products and database, but probably less good on the desktop. And I've heard from a lot of people that QGIS has really evolved, and they see it for a lot of workflows being a valid alternative to ArcGIS for desktop work. Mentioned my own company, Ubisense. So, you know, we do a closed source product, but we build on a lot of open source work for doing web and mobility applications. And then the OpenStreetMap project, which I mentioned, and I assume everyone's familiar with, uses a lot of open source in its work. So their main editors, the ID editor here, are all open source. So it's just to try and give you an idea of the breadth of the open source world. And while I'm mentioning OpenStreetMap, I thought I would also just mention that another interesting conference that's coming up soon is the State of the Map US, which is going to be in Boulder, beginning of October. And I've always found that and so that's the conference focused on OpenStreetMap. And I've always found that a really interesting conference with a lot of energy. It's really not expensive to attend. If you're paying for yourself, they ask you to pay a bit more if your company's paying. But so I'd recommend people look into that as well. But so overall, in summary, I'd just say there's kind of a parallel geo world out there if you're not familiar with open source, and I really would encourage you to look into some of these things. I'll share these slides so you know you can look at those if you want to look around. I'll just talk briefly about mobility, and then we'll go on and talk to the future. But I think, like I said, mobility is a big trend right now. It's one of the main things that I'm particularly focused on. And I'd say there's a couple of important things to consider here if you're developing solutions or looking at solutions. We're in this interesting stage where you know you can have an online connection most of the time, but not all of the time. And for our customers, they really need to know they can use things in the field all the time, so they need to be able to work offline. But at the same time, there's a lot of advantage to being able to work when you're online and having more real-time access to data. And so you really need this kind of hybrid online-offline architecture. And from what we've found, this is something where all these kind of mainstream developments don't really help you. You still have to write a lot of just heavy-duty, low-level code to enable this. But you know, overall, I'd say enterprise-scale sync architectures are quite complex, and so this is still an area that you know there's quite a lot of difference between systems on, and you know a number of unsolved issues. The other important thing to think about with a mobility strategy is what operating systems, and you know the market is fairly fragmented. Android and iOS both have strong shares, and in the sort of enterprises we work in, Windows has a large share too. So I think it's very important to have a cross-platform mobile strategy. There's three main approaches to developing mobile apps. This is nothing to do with Geo. This is from the Salesforce website. Native, hybrid, and HTML5. And in the interest of time, I'll just say I feel very strongly that hybrid is the right approach for most geospatial applications, you know, unless you're doing really heavy-duty augmented reality things or something like that. But for basic 2D mapping and even 3D mapping, on the whole, hybrid approaches are very good. And really what they do is they let you develop one set of code in JavaScript web technologies, use technologies like PhoneGap is probably the best known one, or Apache Cordova is another name for it. And then you can effectively compile onto all these different platforms. So you write code once and deploy it to all the platforms. But with a hybrid approach, you can have access to local storage, which you don't have with HTML5, which is the other kind of cross-platform approach here. I'll just briefly mention general IT trends, which I think are important, and then we'll talk about the future. So I mentioned briefly before, but there's a number of things that fall into the category of the cloud, which I think are really interesting. And for me, especially the enterprises I work with, say utilities, communications companies, I see the gap between internal IT organizations and what people do in the cloud widening. I mean, it's just getting faster and faster to do things in the cloud and use techniques that are there. And a few things I'll just mention that are worth looking at. Containers is a very popular thing. There's a product called Docker, and it's like a lightweight virtualization thing. It makes it super easy to install things and to manage multiple server processes. So, for example, and then there are tools that manage these Docker containers, and those are generally known as orchestration tools, things like Docker Swarm and Kubernetes. So if you're managing a web application, you can just write one of these containers, and then you don't have to worry about what runs on which server. You just kind of pass it over to this whole container infrastructure, and it looks after where things run. It makes things so much simpler to manage, and it's the kind of thing that is used by the Facebooks and the Googles of the world in managing these very large sites. Microservices is something that people talk about in this context too, and it's kind of a different style of writing your server software, where basically instead of having one really big application server, you might write a service for search and query and selecting features on the map. And then these systems can manage how many of each of these services do you have running. So it just takes a lot of the headaches away from managing large IT infrastructure. Serverless architectures is an in thing. I was at the FOSS4G open source conference recently, and there were lots of presentations about this. It's rather confusingly named because it doesn't mean there's no server, but it means you can write code in a way where you don't have to worry which server it's running on. So in a sense, it's an extension of this container idea. And then the last thing, which I think is strong in the cloud, is the idea of continuous deployment. So for a long time, Google Maps has done 2 software releases every week. And, you know, most enterprises maybe do 1 a year in a lot of things. And there's just this huge gap, and there's a lot of techniques that they use. So I think that it's going to be more and more compelling to move things to the cloud where you can take advantage of these things. You know, the biggest argument people tend to make against it is security, but I think on the whole, most of the security arguments aren't valid. You can make it equally secure in the cloud. So anyway, I just wanted to mention those things, but I think that's a trend that we'll see that will impact the way that we deploy systems. So before I go into the future, just say where I think the biggest change was in the time period that we've reviewed. Now we've caught up with the future. I would say the general geo industry, I think the biggest change was between 2003 and 2010 for me was the introduction of Google Maps and the iPhone and the iPad. I think those are the things that are still having the biggest impact on the industry and will continue to do so. For utilities and communications, I'm afraid to say I really think it was 1989 to 1996 when Small World came out, introduced all these new ideas, which then pushed Intergraph and Esri to develop new products. But most utilities in particular chose their systems in the 1990s, going up to around 2000, and are still using the same system today, 20 odd years later. And you know, have maybe brought in a little bit of these new technologies, but in many ways that whole space is ripe for another change, I think. But it is complex to make those changes. Okay, so let me move on to the future and talk about some interesting things. So we'll start to look ahead towards 2024, but in order to do that, I'm going to talk about a number of things that are happening now, and then we'll kind of extrapolate a bit. So I think the big change that we're going to see with this highly scientific graph here is we're going from having not enough data to way too much. And so, you know, at the moment there's still lots of things where you think, well, it would be nice if I had that bit of data and that bit of data. But I think by 2024 we're going to have just so much data, it's going to be incredibly difficult to filter out the data that we actually want. And so there's a few related things, but a term that I quite like is reality scanning or reality capture is something that there's generally a lot of technologies that are being developed in this space. And really one of the first things in this area was a product called Microsoft Photosynth, which actually came out in 2006. And I thought this was super cool at the time. These are pictures I took of this pole just all independent pictures with no georeferencing, but you can build it into this continuous model where it just works out how they all relate to one another. And then as part of doing that, it also builds this point cloud model. So again, this is all just non-georeferenced pictures. And this is an 11-year-old technology. And I think it's one of a number of examples where Microsoft has either developed or acquired super cool spatial technologies and then just seem to not know what to do with them and let them drop. And this is no longer supported. But there's a lot of sort of successors to this which take it one stage further. There's quite a lot of apps on the iPhone that can basically scan real-time or scan 3D objects just with a camera. And there's this one, I don't even know how you pronounce it, whether it's Turnio or Trinio or whatever, but I just tried this out in the last few days. And it's pretty cool. You just move your phone around a 3D object. You can check out the website here. I don't have a video of this one, but you can move these objects around in 3D, and they're really, really impressive level of detail. And it's one of a whole bunch of apps that can do that. So this technology in general of having multiple photos or a video and being able to build 3D, very high-res 3D objects out of it is pretty well established now and able to easily run on an iPhone. This is a free app. There's a lot of 360-degree cameras around now, and again, I'm sort of interested a lot in what's happening in the consumer space. I'll touch on some things more focused on the sort of enterprise space as well, but in many ways, I think for getting data capture out in everybody's hands, what's happening in the consumer space is interesting. So these 360-degree cameras capture this video, so you can just walk along with them. People use them a lot for action things, but you can look in any direction as you're watching the video, and so there's an infinite number of ways to watch the video. And again, obviously that's very interesting for you mount one of those on top of a truck and drive along a street. You've got a Google Street View-like thing. The iPhone 10 has some really interesting developments, and especially in the camera front and in augmented reality. And I'll just play a little video here that digresses a little bit, but I think it's kind of an interesting video. So.
Our new True Depth camera system, contained within this tiny space, uses extraordinary depth sensing technology to let you unlock your phone with a glance. We call this Face ID. It maps the unique geometry of your face with over 30,000 invisible dots. This data is analyzed by the neural engine on the A11 Bionic chip, the first of its kind. Your iPhone now recognizes you, even in the dark, and will adapt to your physical changes. This makes your face your secure password. So with just a look, you can authenticate your phone or use Apple Pay. The True Depth camera also enables new experiences, like bringing emojis to life by mapping more than 50 facial muscles in real time, so you can be happy or sad or cross. Both the front and rear-facing cameras now have portrait mode, and for the first time you can actually define the light in a scene. Based on fundamental photographic principles, portrait lighting produces the effect of real studio lighting. On the back, the dual camera system is completely redesigned. It's made even smarter by the A11 Bionic chip. With machine learning, the camera detects elements in the scene to optimize the image before the photo is even taken. The camera we use every day now delivers so much more. And as iOS becomes the world's largest platform for augmented reality, it will redefine what's possible. This is iPhone 10.
So I think that there's a couple of interesting things to comment on there. One is just the face recognition. As they said, they're recognizing 30,000 3D points just on your face, and obviously that's geared to being very close range, but nevertheless it's an interesting aspect to this whole capture technology that's very sophisticated. They now have double cameras both on the front and the back of the phone, and if you have a double camera, that makes this sort of building 3D models possible with even greater precision and accuracy. And you know, those examples I showed before just work with a single camera too, but with a double camera there's that much more you can do. And then they also mentioned just at the end that there's really been a huge focus on augmented reality and this AR kit with the new iOS 11, and the iPhone 10 has support for some interesting things there. And I have a couple of friends who've worked in augmented reality for a long time, and they say that's a real game changer. And so I'll just show you a little example of a cool thing you can do with that augmented reality AR kit stuff. So I think some really interesting, cool tools there. Obviously, less focused on the sort of completely automatic capture, but I think it's super impressive how well the virtual world locks onto the real world with this new AR kit stuff. It's just an order of magnitude better than certainly anything in a phone before. I'll give you one other augmented reality example, and then actually, so this is focused on aviation, private pilots. It's a company called Aeroglass, so it's a more specialized augmented reality technology, but probably one of the more accurate ones out there. I'm actually on their advisory board, partly just to keep up with some of the things that are going on in augmented reality. But they have this little map that helps them track their head movement with an upward-facing camera, so it's very, very accurate. But I think the precision that they lock onto the runways and other things with is really very impressive. So this is all actual footage, not just simulated. And then switch to a car now, obviously. So just another little look at augmented reality, which is a slight diversion from the data capture stuff. I'll just mention a few other examples of sort of reality capture. I have a couple of slides here that Jeff Zeiss kindly gave to me. Jeff's in the audience here, and I think he's doing a presentation later on underground sensing. But Jeff gave a really interesting presentation on a lot of these technologies, and so he was kind to share some of these things. So in addition to the consumer-focused things I've talked about, there's a number of tools that are focused more on enterprises and so on. And one of them he mentions here, the Leica BLK 360 is a significant step forward in that sort of space, and I'll just show a quick video of that. So there, you see it's scanning that area, which is 60 meters radius, so about 200 feet radius, just in a few minutes to an incredible level of detail. And those are still moderately expensive, but way less than, I think, in the order of $15,000, but way cheaper than comparable devices before. And there's a whole host of these kind of scanning devices. Again, this is a list that Jeff sent. I had a quick look at this structure one, which is a $400 thing that you can attach to your iPad, and that was super impressive. But I didn't include a video in the interest of time here. Structure from motion, or SLAM, is another interesting thing where it's a sort of related technology, but what this is doing is both capturing information about your environment and also telling you your position by interpreting the image. So as you walk around a room, it builds the model, but it can also tell you where you are by recognizing what it's captured. So it's this kind of clever two-way thing. And then drones are another interesting thing, and there's lots happening in the drone space, including a lot on the enterprise front. But again, I sort of think there's some very interesting things happening in the consumer space. So I'll show you a quick video of the latest DJI drone, which I think is super cool.
Meet Spark. Small, colorful, smart. A powerful flying camera that you can take anywhere. It's so clever, it activates by recognizing you. Just launch it from the palm of your hand. It even returns when you call it. And land like this. Easy. Can't get everyone in the shot? No problem. Watch as it hovers precisely in place, always at your command. Control it with your hands, remote controller, mobile device, or DJI goggles. Using GPS, Spark knows where it is, even if you don't. It'll even sense obstacles to avoid things in front of it and come home safely. Think you got smooth moves? Spark's footage is smoother. It takes the shake out of your shot, so you look like a pro. Not feeling the control sticks? Perform preset flight maneuvers with a single click and get those epic shots. Here's a way to stand out from the crowd. Spark automatically adds shallow depth of field to your photos. If you don't know how to fly, just tap fly. Let's see if you can handle sport mode. Spark keeps you in the frame, so all you need to do is act naturally. Edit your epic videos and share them instantly. Spark your aerial creativity anywhere. All you need to do is seize the moment.
So there's quite a bit in there that is more consumer focused, but I have a DJI Mavic, which is a slightly larger one, and it captures incredible quality 4K video and imagery. You can download apps that are free or just very inexpensive to easily create stitch together imagery, 3D models. It's amazing how simple it's all becoming, and as you can see, they're becoming smarter and smarter. So they're definitely going to be another huge data input. And I'm almost good, Christy. A couple more minutes. I just mentioned briefly, this is another slide from Jeff. There's a lot of interesting things happening on the satellite front. People like Planet Labs looking at incredibly frequent satellite updates. I won't go into detail on this slide. But one thing that is going to be very important, is very important with all this sort of great rush of data is sort of image recognition. And this is a great site if you look at my slides afterwards. I saw this demo in a presentation the other day and thought it must be faked because it worked so well. But what you can do here is click on something on the map. So I click on a wind turbine here, and it finds 1,000 matches for wind turbines that it thinks are the closest, and you can see them down at the bottom there, and it's so pretty much instant. And I thought it must be pre-cooked, but when you go and play with it, you really get some interesting results. So I definitely recommend a quick play around on this site. It's very interesting. And so then I think the final video I'll show you is one from Tesla, and I think that we heard in the opening remarks about what's happening in the sort of self-driving car industry is really very interesting, and I think it's going to drive a lot of things. So this is a video from Tesla, and all the new Teslas have either 6 or 8 high-def cameras in them. And so here you can see a Tesla sort of car driving autonomously, and you see the view from 3 of the cameras there. And so it's identifying in real time all of these objects. So it's finding stop signs, traffic signals, other cars, people, and, you know, with the smarts to know what those things are and how to react to them. So in many ways, I see this being kind of the accumulation of a lot of these technologies I've been talking about, of not just recognizing things, but doing it in real time and really applying a lot of intelligence. So I think that what's happening in the sort of self-driving car space, which is just getting massive investment, is really going to have a huge impact on us in the sort of more traditional geospatial industry. I think if you just think about how that's going to develop, I mean, basically every Tesla car is capturing that information all the time. They feed a lot of that information back to Tesla, and so they're capturing these enormous data volumes. But, you know, if we go back to 2020, or go ahead to 2024, which is what we said we'd do, I think, you know, our brains are going to be exploding a bit with all the data that's coming in. But in particular, if you think about that car scenario, I mean, by that point, really, probably every car is going to have that kind of those kind of sensors in. It's probably going to have LiDAR type of sensors too, in addition to the photography. There's going to be a very strong motivation to communicate between cars. I mean, it's, you know, there's a pretty good chance a lot of those cars will be self-driving at that time, but you're going to want to share information about any changes you've identified. Change technology is going to be really important, you know, to know if there's something different from when the previous person drove by here or when you drove by yesterday. And so, you know, that's going to be just, I think, radically different, or have a radical impact on the way that we do data maintenance in the traditional geospatial industry. So here's just a quick list of some of the things that I think will contribute to data update. You'll have cars, drones, you know, much smarter, smaller, longer lasting than the ones we saw. Phones, glasses. We didn't really talk about glasses, but certainly for work purposes, glasses are going to be a good input and output mechanism. Satellites. And then you'll have both imagery and video, both in real time and historical. So, you know, it's quite likely you can just go and look at a main road and see at any given point, get live video feed from what's happening now, but also video feed at any point during that day, really. I mean, that data is all going to be there. There's going to be a strong incentive to develop ways to share it. So smart feature recognition and change detection is going to be really crucial. That's been mentioned a few times, and that's going to be an area that's going to get massive focus. And so overall, I think that with a lot of the kind of databases that we work with, you know, where you're mapping infrastructure and that kind of thing, you're really going to move to a self-updating database model. You know, as you install things in the field, a combination of these kind of cameras and other sensors will just record what you installed. And the role of GIS as kind of a manual way of updating that data, I think, is there's a good chance that's just going to go away completely. So it's going to be a major change. But, you know, with a lot of obviously very exciting possibilities for what we can do with all this extra data. And then finally, mixed reality, augmented reality is going to be a major thing. You've got a flavor of that there, but, you know, with another 7 years of development, that's going to be huge. And sort of people working both in the office, looking at the virtual reality view of what's in the field, and people working in the field, looking at things overlaid. So it's going to be a super interesting time, I think. So that's it. I've just gone a little over, and I know Christy has a couple of announcements to make. So I should probably stop there, but I'll be around if you want to ask me any questions. Thank you very much. Do you want to take questions? Yeah. Is that it? Yeah. Sorry. I think that's on. It just takes a second.
Or not. There
Yeah.
we go. Thank you. Thanks, Peter. We look forward to seeing you in 7 more years, right? Okay. So I just want to go over a few announcements before we let you loose for the break and refreshments. So let's go over schedule of activities for today. One Compass, they have a lot of stuff going on all day. Tailgate party outside on the patio at lunch. They're doing drone demos throughout the conference. They're going to be doing, well, let me back up, I'll get to that. Exhibitors outside in the hallway and in the Colorado Lounge all day. The poster session is in the Upper Mountain View room that's across the hallway. Voting is open until 4 p.m. Poster presenters will be there until, they will be there from 3 to 3:30 today for questions. And then they will be at the social as well for the prizes. Sessions start today at 10:30. Lunch today and tomorrow is at 12. That will be in the Upper Mountain View room and outside. So for when we have breaks and lunch, it'll be in the Upper Mountain View room and outside. They'll be set up in both places. The social tonight starts at 5. It'll be again it'll be in the Upper Mountain View room and outside on the patio. Is that right, Paul? Is Paul in here? I believe that's right. So join us for drinks, appetizers, and the ever-popular Geo quiz. Poster winners will be announced. The One Compass Spark drone that you just saw, giveaway will be then, and there will be raffle prizes given away. Day 2, sessions start tomorrow at 8:30. 8:30, everybody remember that. That's earlier tomorrow. Aileen Buckley's keynote will be tomorrow at 1 o'clock. The Career Development Academy, that starts tomorrow at 2 o'clock in the Conifer Evergreen room, which is just next door. This year's CDA focuses on career transitions. Session is designed to be relevant and welcoming regardless of your career stage. It's a facilitated panel discussion. It'll explore how to best prepare for career transitions and how to thrive in that new position. Following the panel discussion, GIS experts will be available to conduct resume reviews and give you pointers on how to help your career transition. Remember to bring multiple copies of your resume if you want to do the resume review, because you'll be able to have multiple people review that. Sign up is at the registration desk. Let's see. Tours, there's still space available in tours for the Botanic Gardens. There's 20 spots left. It starts at 1 o'clock at the Botanic Gardens in Denver. It's $14 a person. Celestial Seasonings, there's 40 spots left. That's in Boulder at $115, and it's free. And the Stranahan's Whiskey Distillery, there's 18 spots left. It starts at 4 o'clock, and it's $10 a person. These are all on Friday. If you've already registered, you should have received an email with details on where to park, where to meet, and other important details. So look for this email if you've already registered. Okay. Let's see, Wi-Fi. There is a free Wi-Fi access. The network is Hotel Inverness Conference. There's no password. Okay, you should have received an email about our new guidebook app. So we tried a new thing this year. It's called Guidebook, and it's a digital program. Because we didn't budget for this year, we had we piloted it. We only had 200 free downloads because, again, it was a free. We had to do a free program. So we only have 200 downloads, so obviously everyone's not going to be able to do it. It's a first-come, first-served basis. It has a little bit of limited functionality. There's still downloads available, so the way you're going to do it is on your iOS or your Android phone, you're going to download guidebook. It's free. You're going to search for GIS in the Rockies 2017, and that's all you have to do. So if you want to do it, you can do it right now. And if you do it, you can give us feedback either verbally or when we send out a survey, we send everybody out, after the conference is over, we send out a SurveyMonkey survey, and we'll include some questions in there. We would love to have your feedback because that will help us make a decision on if we're going to actually pay for this and do it again next year. All right, that's it. So snacks are available across the hall in the Upper Mountain View room. Sessions start at 10:30. And you're free to go. Thank you. Enjoy the rest of the conference.